Material UI is one of the most popular JavaScript user interface libraries used to create websites. But what exactly is it? How is it built? And is the quality of the software up to modern standards? In this video, we will detail our analysis of the architecture of the Material UI project. In 2014, Google announced its new Material Design language that would eventually be used for all of Google's services from Android to web services. Although Google has created its own official implementation of material design for websites, called Polymer, many software projects nowadays use a library called React to create their user interfaces. The most popular project to implement the material design language for React is Material UI. Material UI is built using React, JavaScript, and Node.js. It currently supports all major modern browsers, and there is currently still support for Internet Explorer, although that will be dropped in a future release. Although its name is strongly inspired by Google's design language, it is not created by Google, it is not proprietary, but is a standalone project that is free and open source instead. So let us now take a look at what this project exactly is and how it is being developed. In React, each user interface element is a component. This allows developers to quickly create user interfaces by composing components. Material UI is a JavaScript library that gives developers a set of these aforementioned user interface components. But Material UI doesn't just supply nicer styles for standard components, it also adds more complex components that developers often need to implement themselves. Amongst other things, it adds tabs, grid layouts, and modal dialog boxes. Once an application using Material UI is up and running, each of the components can be loaded as one big bundle. However, it is also possible to use a modern module bundler so that only the components you use are included. This results in a smaller bundle, so the pages can load faster. A developer simply declares that a certain component should be rendered, and React will schedule the component for render. The behavior of components can be changed by specifying so-called props, which are values that can be passed to the components. Finally, the component is rendered and can respond to user interaction.
So, who are the stakeholders involved in Material UI? We first have the core developers, currently consisting of 5 active members. They are the folks who are responsible for the project and have the final say over what does and does not get into the project. Next, we have the community. Community is one of the main aspects in Material UI. The general direction of the project is decided by a show of interest from the community. This is done by either showing interest for certain features as a user or by creating your own pull requests. And then we have the people who use Material UI in their own projects. These are the people that make Material UI relevant, as what would the project be without any users? The users can range from individuals who have created a small web application to larger companies working on projects that serve a much wider audience. There are various products that provide similar UI design options to Material UI. Some examples are Ant Design, Flat UI, Kendo UI, ReactMD, Bootstrap, and Materialize. While some of these use different technologies, they all provide help with designing consistent and efficient user interfaces. Some are less popular or not as well maintained as Material UI, while others try to. The most comparable is Ant Design. Various tools are used to support the project. For documentation, we have Netlify and Crowded. For development and testing, we have GitHub, CircleCI, BrowserStack, and CodeComm.
The project uses a layered architecture model, where the various components all extend the core components, which provide the common functionalities. It also uses a component-based architecture. The components can all be combined and composed to further extend the range of possibilities. The project uses pull requests on GitHub to propose changes. The core team reviews these proposed changes on correctness and code quality. If they fully agree with the changes, they will approve and merge the pull request. If they agree with the proposed changes, but disagree with the style, they will request further changes. If they disagree with the changes entirely, they will reject the pull request. Before any pull request can be merged, there are 15 different continuous integration pipeline checks that are performed. These checks verify that all software tests still pass. If the test coverage is sufficiently high, and if the documentation is updated accordingly. SonarCube gave the project an A for maintainability on all components. Software Improvement Group also reviewed the project and gave some interestingly low results. The unit size was graded 1.6 out of 5 and the unit complexity 2.3 out of 5. We investigated this and found that this was caused by React components consisting of a single function. This is a somewhat common pattern in React projects and cannot be easily fixed within Material UI. Technical debt can be seen as a cost that has to be paid to rework a certain aspect due to quick solutions being chosen instead of good solutions. The most technical debt has been accumulated in the CodeMod and core packages. To test the library, Material UI uses automated tests that are executed in the continuous integration pipeline. There are several types of tests. Some are unit tests, some are component tests, and then there are integration tests. The test coverage of the Material UI project is relatively high.
New components are not immediately added to the core of Material UI, because one of the goals of the project is to avoid incompatibility between versions as much as possible. New components often have overhauls or breaking changes during the initial development, which are therefore not desired in the core. This resulted in Material UI creating the lab package. New components are first added to the lab package, and only when they are deemed stable, well tested, and of high quality are they added to the core. Previously, we have told you about the importance of the community aspect in the Material UI project. This is again prevalent in the planned future for the project. Instead of the classical roadmap with set goals for the near and far future, Material UI only has a list of options and wishes for the future. This way, they give room for the community to decide by allowing them to up or downvote the choices on GitHub. Additionally, the issues on GitHub are not limited to those seen on the roadmap. Any community member can start an issue to discuss the potential futures for the project. Currently, these items are on the roadmap. We hope that this video has given you a good introduction on the architecture of Material UI. For a more detailed view of the architecture, visit the link on screen. This website also contains the sections of other projects.